Welcome to InventorCAM Professor on our series of Getting Started. I'm Sydney, your InventorCAM Professor, and in this session we'll be showing you how to mill out a 2.5D part as shown on the screen. I'd like to take this part, and as you can see in this part I have to mill out this side, including the face and these steps here, and on the second side I have to mill out the slot, these pockets, and so on. I'll start off by creating my home position. First I'll go into InventorCAM and start a new part of milling. Now I'll save this part. This is the area where I want to save my part itself. And this is the part that I will be saving, and this is the name of the part that will be created in InventorCAM. Now you'll note automatically this part is put into an assembly mode in Inventor. Okay, I'll continue on by defining my home position. And I'll start by defining my home position in the simplest way by simply clicking on this face here. And I will automatically get a home position in the corner of the part. Now if I want, I can go pick origin and pick a different point over here, move it around wherever I want to. But I'm just going to leave it right now in that corner where I want to have it. Now simply say finish. In the next window that pops up, I'll have my start level, my clearance level. This is the level where it goes up to every single time the tool goes from one area to the next area while you're doing your operations. The part upper level, which is 0, and the part lower level automatically measured to the bottom of this part, and I'll simply say OK. Now I have to create another home position on the other side, so I'll simply right click here and I'll add a new home, and I'll flip the part over, and I'll simply click on this side, and I'll get now a new home position exactly on the other side, and I'll say finish. Now I have two home positions for my part. As you can see, since the depth is the exact same thing, just flip side, I have the exact same value over here. I'll say OK, and these are the only home positions that I need for this part right now. Now the next thing I'd like to do is simply create a stock around the part. I'll simply click on Start, and I'll do it by creating an automatic box around the part. I'll simply click on Define, click on the part itself, and you'll note that there's a box that's automatically formed around the part. And these values here are the excess material, how much the box is being expanded on each side, whether it be X plus, X minus, Y plus, Y minus, Z plus, and Z minus. I'll simply say finish, and I've created my stock material. If I do show, you can see that this is the actual stock material that I'll be able to see while I'm doing my simulations. Now I also have a target which was automatically created through my settings. If I show my target, this is actually the final part which I want to get up to at the end, as shown over here. Now I'll simply say save and exit, and we're ready to start our operations. In my first operation, I like to mill out the face of this part itself. So I'll simply start with my operations and go to Add Operations and choose the option of Face Mill. Now, in my coordinate system, my geometry, I have to choose which coordinate system I'll be working on. In this particular case, I'm working on coordinate system position 1. And I'd like to now define my geometry. My geometry, I'll be basing it on the model itself. So I'll simply go into Define and click on Target, and you'll note that I'll have a boundary around the entire part itself. The next thing I like to do is choose a tool. The tool that I'll be choosing will be a 20mm and mill. Now I know this tool is not big enough to cover this entire part, so we'll see exactly what kind of technology we'll use to mill out the face of this part. Now my levels, I have my upper level and my face depth. My face depth is actually up until the face over there, as you can see. And we have my technology. Now in my technology we have a few options. We can either work hatch going back and forth on the part as shown here. We have contour, and we also have one pass. Now one pass is good if my tool is big enough to cover the entire face of the part. It'll do one pass down the middle of the boundary of the part. In this particular case, since my tool is not big enough, I'll choose the option of hatch. Now in my data area, we have the angle that I want to work on. In this particular case, I use the user-defined angle, leave it at 0. And we have in our extensions. Our extension along the length is how much do I want the tool to go past the part itself. And we can work either the percentage of the tool or a value itself. And the same thing across. How much of the tool do I want to go across the part itself. Now, I also can work in zigzag, going back and forth, or one way. In this particular case, I want to work zigzag. And I can also add a fillet, a radius path as I'm going from one pass to the next. I'll simply click on OK, and in my offset area I can say, alright, let's leave 0.2 millimeters from the floor of the part and then do a finish cut. Now I'll do save and calculate and do a simple simulation, and with the simulation I'll use right now will be solid verify. You'll note that the tool will go down one shot at a time, and you notice the tool goes down up until the bottom of the part itself, and then finishes off the part as we're going along. My next operation, I like to mill out this step around the part as you see here. I'll simply start a new operation, and this time I'll be choosing the option of profile. Now in my profile operation, again I'll be using position 1, and my geometry will be this edge around here. So I'll simply click on this edge, and I'll create a chain automatically by going automatic constant Z, and you'll note that the chain was automatically taken around the part, and I'll simply say finish. That's the toolpath I like to work on. The tool that I will be using will be my second tool, is 16mm and mill. Now in my levels, my upper level will be the top of the part as shown here, and my profile depth will be up until this step over here. Now in my technology area, I'll be choosing to work on the left hand side of the part as shown here. These are the default values, by the way. I'll be working depth of constant, going down every single time the amount I need to go down. And let me go now into my rough area. In my rough area, I'm going to leave 0.5 millimeters for finish cut, and I'll be going down every 5 millimeters of the part. And you'll note that since my profile depth is actually 5 millimeters, so I'll actually be able to do this in one shot. Now, I will also do a finish cut on this part with one pass around the part itself. One other thing I like to do is I also like to use my clear offset. What clear offset will do is actually start from the outside, further away from the part, go around, and then go in again. I'll have my clear offset set at 5 millimeters and step in every 2.5 millimeters. And I'll be working either zigzag or one way. In this particular case, I'll be working one way since I'm going around the entire part itself. Now, the last thing I have to do is my links. How do I want to approach the part, and how do I want to leave the part? There are many ways of doing it. One way is doing by tangent, where I go in from the side and move in by specific value. And this is what I'll do right now, and I'll have it go in with a tangent of 10 millimeters. Since my lead out, I want it to have the exact same as my lead in, I'll simply click on same as lead in, and I'll automatically get the exact same lead out as my lead in. I'll simply do save and calculate and simulate. Again, I'll choose the option of solid verify in my simulation, and you'll note that my tool will go down, step in, and basically now finish that entire step that needed to be milled out. My next operation, I'd like to actually mill out now the outside of this part. I'll simply start another profile operation, and this time my geometry will be the outside boundary. So again, I'll choose define. I'll click on this line over here, but this time you note the direction is going in this direction from this side to over here, and I want to reverse. I simply click on reverse to change the direction. Again, I'll choose the option of auto constant Z, and it'll automatically create a boundary around the part, and I'll accept this chain. Now, the tool that I'll be using the exact same tool I used last time, my 20mm end mill, and of course I have to go into the tools area. I'll use a 16mm end mill this time, as I did last time. My levels, since I've milled down till this level already, I can simply click on that field for my upper level, and my profile depth will be to the very bottom of the part over here. Now simply click on OK. Now in my technology area, again I'll be working left. I'll be doing a rough cut, leaving a 0.5 millimeter, and I will also be doing a finish cut. I will not be using, however, clear offset in this particular operation. I don't need it this time. Now in my link area, this time I'll choose the option of arc, allowing me to go in an arc fashion, and I'll choose 12mm arc, and I'll do the same for my lead out, and then do save and calculate. Now if I do simulate, in our simulation, this time we'll use the simulation of HostCAD just the way it is, and we'll use our top view so we can see it a lot better. You'll note that the tool, and I'll do this one step at a time, goes in an arc fashion, as shown here, goes around the part, and then leaves with an arc fashion, as shown here. In my next operation, I like to now mill out these areas as shown over here. So again, I'll start a new profile operation, and this time I'll choose my geometry on these edges over here. I'll simply do define, choose my first one. This time I'm choosing the option of curve, and I'll accept this chain. I'll do the same thing with the other chains as shown over here, and I'll choose this time this one, accept that. I'll do my third chain on the other side and accept that one, and last and definitely not least, my last chain over here, and accept that chain as shown here. Now I'll finish my choosing of geometry. The tool that I'll be using this time will be my 8mm end mill. Now my levels in this particular case, my upper level will be this floor over here, and my lower level, my profile depth, will be this floor as shown over here. In other words, I'll be going down a total of 2 millimeters. My technology, I'll be doing both rough and finish, leaving an offset of a 0.5 millimeter on my wall offset, and again I'll be using a clear offset of, say, 4.5 millimeters, and a step in of 4 millimeters on the part itself. My link, I'll use a link of arc, and my lead out will be the same as my lead in. Now when I do save and calculate and simulate, and this time I'll use the solid verify simulation, first of all you'll note that my part has been updated automatically as far as the simulation goes up until that point. Now when I do the simulation itself, you'll see the edges are now being completely milled out exactly the way it's supposed to be milled out. Now, my next operation, I like to start actually working on the flip side of the part. To start working first with doing a face mill on this side of the part itself. So I'll start a new operation, and again I'll choose the option of face, but this time when I start my coordinate system, I'll start this time using Mach 1 position 2. When I go to define, again I'll choose my option of target, and again it created a box around a border around the target itself. The tool that I will be using will be my 20mm and mill. My levels, my upper level, I'll have it at 2mm because that's my excess material up on top of the part. And my face depth will be up until this face over here. In my technology area, again, I'll be using the option of hatch, exactly the way I had it before, leaving 0.2mm and then doing finish. Doing save and calculate, you'll note in my simulation, and I'll use this solid verify simulation, my tool will go down, clean the part, and do my last 0.2mm, and now my part is completely ready to be machined within the pocket itself. In my next operation, I like to mill out now this pocket. Now if we take a look at this pocket, we have to go from this depth up until this step over here. That would be one pocket, being only the outside geometry. And my next pocket will be from this depth, from this step over here down to the bottom, which then include these two islands. I'll start my new operation, and this time do a pocket operation. When I choose my geometry, again note, I'll be using Mach 1 position 2. When I choose my geometry, I'll be using this geometry over here, as shown around the part itself. The tool that we'll be using will be my 16mm and mill. And my levels, my upper level will be this surface over here. And my pocket depth will be up until the top of the step itself. In my technology area, we have several ways of working on the part, and I'll be using the option of contour. And in my link area, I'll be ramping down in a helical fashion as shown over here. And I'll have a lead out of an arc. Now, when I do save and calculate, and then simulate the part itself using my solid verify, you'll note that the tool cleans out this entire pocket area. Next operation, I like to do now the bottom pocket. So I'll continue on with a new operation of pocket. And this time when I choose my geometry, I'll use a different method choosing the geometry, because this time I'm including my pockets. I'll simply go to multi-chain, click on the bottom floor itself, and you'll note that it'll automatically pick those chains around that we have over there, including the outside border as being the first border, and then the islands within. I'll choose a tool, and I'll use this time the exact same tool I used last time, my 16mm and mill. My levels, choosing my upper level will be the top of that island over there, and my pocket depth will be up until the floor itself. Now in my technology area, I'll have a wall offset of 0.2mm, and the same on my island offset, and I'll even leave a little bit on my floor offset as well. Now in my link area, again I'll choose the option of link in using helical, and lead out using an arc of 2 millimeters. I'll do save and calculate, and in my simulation you'll note this time that the tool will work within this area over here, and it can only go in to wherever it can go, and it cannot go behind these areas as well. Now, my next operation, I still have to clear out these areas over here, which I was not able to go into before because my tool is too big. But I want to base it on this particular operation which I just did, so I'll simply do save and copy, and I've now created a new operation based on the previous operation. That means I have the exact same geometry that I had before. What I'll do now is change my tool, and the tool that I'll be using this time will be a 6 millimeter end mill. Now my levels will stay the same as before. In my technology area, this time I'll use the option of rest material chamfer. If I were to open up this option, I'd use the option of rest as to clean out only the rest of the material, and the previous tool diameter will be my 16 millimeter end mill. Now my previous wall offset, I'll have that at 0.2, and what I'll have here now also, we have here the option of extension. From what area do I want to actually have it go in to that area? How much before do I actually want it to touch to go into that area itself? I'll simply do now save and calculate and simulate. And this time if I do the solid verify simulation of the part, you'll note that the tool goes in and clears exactly those areas as shown over here. Going into those areas, cleaning every single one of those areas. My next operation, I'd like to just work on this wall over here. And just to show you what I'll do, I'll just simply do a simple profile operation to finish it off. So I'll start a new operation of profile. Again, I'll be using position 2, and I'll use this contour as shown here, only that contour over there. Now the tool that I'll be using my 6 millimeter end mill, and in my levels, my upper level will be the top of the step, whereas my profile depth will be up until the floor itself. And since I actually want to clean the entire wall, I'll have my upper level really from over here. This way I can start cleaning it from the top itself over there. In my technology area, I'll be doing just a finish cut. And in my links, I'll approach using a 2 millimeter arc, and my lead out will be the same. Now I'll do save and calculate and simulate. And you'll note in my simulation the tool goes in and clears that entire part over there. But I did this in one step. So instead I'm going to make a little change over here, my step down, and I'll have it do it every 3 millimeters. This time when I do save and calculate in the simulation, you'll note that it does it every 3 millimeters, going down, clearing that entire wall as shown. In my next operation, I like to clean the very top of these steps over here. Now I can do this if I want using face, but this time I want to show you a different way of working using a profile operation. I'll create a new operation of profile, and my geometry will be this area over here, doing auto constant Z, taking this entire chain over here around, and I'll do the same thing on this side. And also doing automatic constant Z, choosing my geometry. Now this time I'll use the tool of 16 millimeters, or I should say I'll use a tool of 8 millimeters. And in my levels, I'll have my upper level as the top over here, and my profile depth will be the exact same thing. Basically, I'm just working just on that level itself. In my technology, instead of left, I'll be using middle. Notice my tool will be at the middle of the geometry itself. The center of the tool will be on the geometry itself. In my link area, I'll be using a lead-in of arc, and I'll do simple save and calculate and simulate. Now you'll note when I do my simulation, it only works on top with the center of the tool going down as shown on the center of the geometry itself. This is another way to clear the top of a surface. Now, in my next operation, I'd like to now finish off the floor of this pocket here. So I'll simply do a new operation, use pocket. The geometry that I'll be using my pocket will be the one including the islands. The tool that I will be using will be and the 6mm end mill. The level, my upper level, will be the floor itself. And since I'm actually going just to the floor, I'll simply re-click the floor itself to have it at 0. In my technology area, since I finished the walls already and the walls of the island, I'll have this at 0.1mm. Same thing at my islands. And I'll leave my floor offset now at 0. I'll simply do save and calculate and then simulate the part. And in my simulation you'll see that it's working on the very bottom of the floor itself up until these areas itself over there, clearing finishing the entire floor. The next thing I like to do is I like to mill out this slot around the part itself. I'll simply start a new operation, and this time I'll use the option of slot. Again, Mach 1 position 2. My geometry, I'll simply use the outside border of this slot itself, and I'll create a chain around the part itself as shown here. The tool that I will be using will be the width of the slot itself, a 1.5mm end mill. My levels, my upper level will be this area over here. Now when I go into my technology area, I'll choose the option of constant. My tool side will not be on the middle of the geometry itself, rather on the right hand side of the geometry. My depth will be up until the floor of the part itself, as shown here. And I'll be going down every 0.5 millimeter. I'll simply do save and calculate, and in my simulation, and this time I'll use the option of solid verify for my simulation itself. You'll note that the tool will go down. Of course, I would like to turn the part over first. My tool now go down, and if I want, I can get rid of the holder so we can actually see it better. Working its way around the part itself, now going down to the next step and completing the entire slot around the part. Next, I like to start with the drilling operations. Now, first start with drilling out these holes over here. I'll start my new operation of drilling. My geometry, by simply touching the face as shown here, it will automatically pick up all of the holes on that particular surface. I'll simply say finish. The tool that I'll be using will be a 6mm drill that has a 90mm tip on it to give it a little bit of a chamfer. Now my levels, my upper level will be that surface over there, and I'll have my drill depth actually be also to the same surface, but what I'll have is I'll have the entire diameter go to this surface over here, which will actually create a 0.5mm chamfer on the part itself. My technology, I'll use a simple drill cycle technology, and then I'll do save and calculate. If we take a look at our solid verified simulation, you'll see that the tool goes down and does up until that area itself. Next, I'd like to do a new operation based on this previous operation. I'll simply do save and copy, and I'll choose just a different tool, and the tool that I'll be using this time will be a 5mm drill. My levels, my upper level will be the same, but my drill depth will be up until this step over here. And again, I'll say use full diameter of the part of the drill itself. I'll do save and calculate, and then do the simulation. And this time you'll see in the simulation that the tool will go through the entire part itself, as shown over here. Next, I'd like to deal with these tapped holes over here. I'll simply again start a new operation of drilling. Choose my geometry again using position 2. Simply click on that floor over there and also on this floor over here to get all of the holes that we need to drill out. My tool, again I'll be using this 6mm 90-degree tool. My levels, my upper level will be that surface, and my drill depth, this time I'll simply write 1mm using the cutter tip. I'll simply say save and calculate, and then we'll continue. In our simulation, you'll see that it's simply drilled out those areas itself. Now, I'll simply do now save and copy, create a new operation, and this time change my tool to a 1.6mm drill, since it's a tap drill of M2. My levels, my upper level will be -4, and my drill depth, if I go into the part itself, I can simply go into the hole and simply click on the center over there, as shown in the hole itself, right over there. And that's the depth I want to go to, using again the cutter tip. In my technology this time I can use a drill cycle type instead of drilling. I can use peck drilling, whereas I go down, every step down will be every 2mm. Simply click on OK and then do save and calculate. I'll go directly this time into save and copy to create my new operation, and this time I'll change my tool to the tap tool that I have over here. My levels, my upper level, my drill depth, this time I'll choose it from the inside of the circle itself, and I'll go down to that circle over there. My technology will automatically be tapping, and then I'll just simply choose on save and calculate. Now let's just do the simulation on the entire part itself. I'll simply do simulate, and we choose the option of solid verify. You'll see that the tool, and I'll flip the part around because we're actually starting on the other side first. We'll first clean out that side, and then work on this side over here, milling out every single part that has to be done, including the holes and including tapping out every single one of those holes. Now the entire part has been completely finished. Thank you for joining us on InventorCAM Professor. Take care and have a nice day.